Okay, this is our second talk on molarity. You should have watched the first video, which was molarity by itself, and now we're going to incorporate in mole to gram and gram to mole conversions because this is very helpful for chemists to be able to measure out the number of grams of a solute and then to dissolve it into a solution to form a certain molarity. So just as a reminder to us here, we do have this molarity formula up here, and molarity is equal to the moles of solute over the liters of solution. And so a couple other things that we're going to take into account here is the mole road, and the mole road's coming back for us. And remember, in the mole road, we did have the mole in the middle, and down at the bottom, we had grams. And if we wanted to convert from grams up the road to moles, we would use the conversion factor 1 mole over the atomic mass or molar mass of whatever substance we were talking about. And if we wanted to go the other way, if we wanted to go from moles down the road to grams, we would just reverse that and we would put the atomic mass of whatever substance we were talking about on top, and we would put 1 mole on the bottom. So the way this incorporates is we're going to use this idea of the mole road, and we can plug this value in over here, or we can use that molarity formula kind of back and forth. And so let's get into that and use this idea of how we can use both of these ideas, this molarity formula on the left and the mole road on the right, to attack one of these mole problems. And so here's a problem down below that we're going to get to right now. Okay, so let's take a look at this guy here. So it says calculate the number of grams. Okay, so first off, we're looking for grams of potassium nitrate, KNO3, okay, required to make 250 milliliters of a 0.175 molar solution. Okay, so let's attack this problem. And so the first thing we're going to do is use that molarity formula. And I like to just start off with the molarity formula and plug in values and just see where it takes us. So we do have 250 milliliters, and as we said before, we want to convert that to liters by moving the decimal 2 places to the left. And so we're going to plug in right here 0.25 liters. Then it's given us a value over here of 1.75 molar. And so now we have 2 of the 3 variables here, and we're going to solve this equation for moles. And so I'm going to multiply both sides by 0.25 liters. And it's going to cancel over here. And then we're going to multiply those 2 values together. Okay, and so the answer that it gives me is 0.44 moles of KNO3. But we're not done yet. And the reason why we're not done yet is we're looking for grams of KNO3, and we're given moles of KNO3. So now here's where we're going to use the mole road. And again, remember, mole road has the mole in the center, and if you want to go down to grams, that conversion factor going down is going to be the atomic mass over 1 mole. And so that's what we're going to do. I'm going to do a second step problem where I'm going to do the atomic mass of KNO3 over 1 mole. And we remember that in order to calculate the atomic mass of any substance, we just have to look at the molar masses on the periodic table, which remember is the bottom number. So for potassium, and we have 1 potassium in KNO3, it's going to be 39.10. Plus we're going to add in 1 nitrogen, which is 14.01. Plus we have, remember, 3 oxygens there. And so oxygen has a molar mass of 16. So we're going to do 16 plus 16 plus 16. And so I get a molar mass of potassium nitrate as 101.11. And that's my molar mass, or atomic mass. Now, I just take that value and multiply it by the number of moles, 0.44, that we determined from using the molarity formula. And so we get a final answer of 44.5 grams of potassium nitrate that needs to be dissolved into 250 milliliters of water if we want to make a 1.75 molar solution. Okay, let's take a look at another problem. Kind of does the same thing, but kind of does it from a backwards way. And so it says, when 45 grams of calcium chloride is dissolved in enough water to make a 0.25 molar solution, what is the molarity? Actually, I have a little typo here. It's really easy to calculate the molarity if we already know the molarity. So this was actually supposed to be 0.25 liters of solution. And so then we're going to calculate the molarity now. And so let's take a look at this real quickly here. So again, we're going to use the molarity formula. Molarity equals moles per liters. And we do know that, like I said, we have 0.25 liters. But in order to calculate our molarity, which is this value here, we need to know moles. And we don't know moles, but what we do know is we know the grams of calcium chloride. So what we're going to do is we're going to do 45 grams of calcium chloride. And remember, on the mole road, if we have grams and we want to go up the road to moles, the conversion factor is 1 mole over the atomic mass. And so what I'm going to do is I'm going to do that conversion, 1 mole over the atomic mass of calcium chloride. Now to calculate, remember the atomic mass of calcium chloride, we're going to have 1 calcium, which is 40.08. And then we're going to add in 2 chlorines, which are 35.45 each. And so I'm going to get an answer of 110.98 grams per mole. And so I'm going to divide that into 45 grams. And so an answer that I get is I'm going to get 0.41 moles of calcium chloride. Now I'm going to take that value and I'm going to plug it in right there. And so I'm going to put in 0.41 moles right there. And then I'm going to divide those two, divided by 0.25, and I'm going to come up with an answer of 1.62 molar. And that's how we do two-step mole problems, incorporating the mole road with the molarity formula to get wherever we need to go with respect to molarity.